Hello, welcome to TechWebDots. In this section, we will discuss about Docker image, right, and understand how we can visualize the different layers that got created during the Docker image creation. And this session is part of the Docker for Beginners series, so I strongly recommend you to watch the previous recorded sessions, and the link is given in the description of this video. So let's move ahead to understand Docker image actually, or we can also call it a container image, right? So image is a package that contains application code plus dependencies. Very important factor to remember, right? Application code plus all the dependencies which are required to run the application quickly and reliably on any of the computing environment, which is the core advantage, right? So how the container image look like, right? So if you see in this image at the right bottom, we'll see the kernel that is coming from the base operating system, and on top of it we have a crate from Ubuntu, the required libraries that our application needed. Let's say we wanted to run application on the Ubuntu OS, right? So those libraries will be included here. Another layer will be the add nginx layer that we specify in our Docker file. Another one is the application layer, and on top of it the one is the writable layer where you can do the file system changes, right? So on the other side, if you see the boot file system, which is our kernel, the base image which is created from Ubuntu, the actual one image layer which is of nginx, another image layer which is of adding application, and top one is the container file system which is the writable. Okay, so let's read more about it, how that looks like, because this is for the single application, but I mean this is not true only for single. You can create multiple one, right? So it will be base kernel, so it can be Fedora on for one of the application you want. For another application you need Ubuntu, and maybe in Fedora you wanted to apply for two application, the Tomcat and Liberty. For Ubuntu you want to use Tomcat. So all possibilities are there, right? And every Fedora or the server, the Tomcat one that you want, the web server, the application, everything will act like a layer. And we have seen once that layer runs, so it caches that layer until and unless we are making changes in that layer. Okay, so container image becomes a unit we use to distribute our application. So this is very important now, right? A container image is immutable. It means you cannot change it once build it. Once you build an image, you cannot change it, right? And container operating system. So the flexibility allow us to access specific OS features or install additional software our application might use, right, within the container. So the container operating system is isolated from the host operating system completely. We have seen in this picture how it works, and it is the environment in which we deploy and run our application, combined with the image immutability, right? It means no one can change it once build it. Another important part of the container image is stackable unification file system. In short, we also call it union file system. Right? Docker uses union file system to create Docker images, and union file system is a file system that allow you to stack several directories. Here, to the directories we call it branches, in such a way that it appears if the content is already merged, means as a single solid box, right? However, the content is physically kept separate. So union file system allow you to add or remove the pieces or the directories as you build your own file system. A final writable layer is created once the container is run from the image. However, this layer doesn't persist when the container is destroyed. It means when the container is destroyed, so there is no layer remaining. Everything is discarded. So what is a base image? You must have heard base image, right? We talked about, and the parent image. So a base image is an image that uses the Docker scratch image. The scratch image means it's an empty container image that doesn't create a file system. It means it's a blank, or you can say the empty container, right? There's no file system, and this image assumes that the application you are going to run can directly use the host operating system kernel, not the container operating system kernel, right? So that that level of image, we call it a base image. Then what is a parent image? A parent image is a container image from which you create your own images. For example, instead of creating an image from scratch and then installing Ubuntu, we will use an image already based on Ubuntu. We can even use an image that already has Nginx installed, right? So a parent image usually includes a container operating system. So that can be, in our case, Ubuntu. What is the main difference between base image and parent image? I know this is the obvious question if you are still having. So let me read it. Both image types allow us to create reusable images. However, base image allow us more control over the final image content. Recall from earlier that image is immutable. You can only add to an image and not subtract. There is a special point to remember. On Windows, you can only create container images that are based on Windows based container images. So Microsoft provides and services these Windows based container images. So I hope the basic of container is clear now.